So, hello and welcome to the microprocessor. It's finished, so I thought I'd take you on a little tour of it. Consists now of around about 40,000 transistors and about 10,000 LEDs. It's about 10 meters long and 2 meters tall, weighs about half a ton and burns about 500 watts of electricity. It can run at a speed of up to around about 8 kilohertz, but I've slowed it down to a hertz so that we can see the lights flashing and things changing. So the microprocessor is a processor, like this one from the old days. And these things are made out of lots of transistors, but very small ones. I've made the microprocessor out of larger ones so that we can see what's going on. And I've also arranged them on little boards so you can see the small low-level logic functions that they're carrying out and how they're all joined together with the wires on a schematic. And I've also put LEDs on the inputs and the outputs so that you can see the logic levels going into a gate and what comes out. So in a processor, there are several functional blocks. One example is the registers, which act as kind of scratch pad when you carry out calculations. So these are the registers for the microprocessor. We've got 4 of them here. The next main functional block in a processor will be the ALU, which carries out all of the arithmetic and logic functions. And that's this area here. So this is the main ALU. We have a second adder up here. So as well as the general purpose registers and the ALU, which does the sums, we tend to have some special purpose registers for doing things in the processor. So for example, we have the program counter, which keeps track of where you are in a program, stack pointer, which also helps in keeping track of where you are in a program and helps with some data flow. And then there's some registers for looking at where we are writing to in memory. So carrying on around here, this is where the instructions arrive first of all to tell the processor what to do. So they arrive up here. And then these 3 modules try and work out what to do for that instruction. So the initial interpretation happens down here, and then these refine that result. So processors carry out a sequence of instructions, and some instructions are complex and need a sequence of operations. And all of that sequencing is carried out by the state machine, which is this module up here. And the last register in the processor is the status register, which is this one here. And this keeps track of the result of calculations, whether the answer was 0 or negative, things like that. So these 5 frames so far form the main body of the processor. Here we start to move into the outside world. So this region up here is the external interface. Now that in the outside world, I use a bit more modern technology to give myself some peripherals. So I've got some extra memory here, and then some timers and counters, and also some I/O, some switches and a joystick, which we'll use a bit later on. And here's the place also where we can control the clock and so forth. So I said at the moment it's running at about a hertz. We can do things like halt the processor. So if you see now nothing much is happening, and I can single step with single clock cycles, like so. So if we get the run gain, we can also change the processor speed. So at the moment it's a hertz. So if I take it up to around its maximum, shade under 8 kilohertz. Up to here. Oops, that won't work. Up to about there. And then the next frame is a small amount of memory, 256 bytes, which I've made in the same way as the rest of the processor with with transistors and LEDs. So you can see the content of everything in the memory. If you ask yourself what you can do with a processor like this, then the answer is you can play games like Tetris. So let's do that. So for Tetris, the idea is to stop the lines getting to the top of the screen, and we can for as long as possible. If I can complete a line, then it disappears. It doesn't look good at the moment. Oh, there is one. Wait. So you can turn the shapes around as they fall to try and make them better fit into the spaces. Oh, yeah, so there's left, right, and I can't do this and talk at the same time. Game over.